Unit 5 Research Design. Research design can be thought of as the structure of research. It is the glue that holds all of the elements in a research project together. We often describe a design using a concise notation that enables us to summarize a complex design structure efficiently. From the previous chapters, you are already familiar with the most basic element, the research question. The significance of a research question has to do with the relevance or point of the answer to it, and the consideration of its novelty, or what new knowledge it will provide. In order to demonstrate what new light your study will shed on an area, you will need to place your research question into the context of what is already known about it, i.e., the review of the literature. The next element is the study design. This unit will throw light on research design and its types. Objectives. After studying this unit, you will be able to state the meaning of research design, describe the purpose of research design, and discuss various types of research designs. 5.2 Meaning of research design. Before starting research, the investigator will look for a problem. She or he will read books, journals, research reports, and other related literature. Based on this, the researcher will finalize the topic for research. During this process, she or he will be in close contact with her or his guide. As soon as the topic is decided, the first task is to decide on the design. Research design is a blueprint or structure within which research is conducted. It constitutes the blueprint for the collection, measurement, and analysis of data. Kothari, 1988, says decisions regarding what, where, when, and how much, by what means concerning an inquiry or a research study constitute research design. Thus, it can be said that research design is an outline of what the researcher will do, from writing objectives and hypotheses and their operational implications to the final analysis of data. Research design should be able to convey the following. What is the study about? Where will the study be carried out? What type of data is necessary? Where is the necessary data available? How much time is needed to complete the study? What will be the sampling design? Which tools will be identified to collect data? How will the data be analyzed? Depending upon the types of research, the structure of the design may vary. Suppose one is conducting experimental research, then identification of variables, control of variables, types of experimental design, etc., should be discussed properly. If someone is conducting qualitative research, then one should stress understanding the setting, nature of data, holistic approach, selection of participants, and inductive data analysis. Thus, according to the nature and type of study, the components of the design will be decided. In short, any efficient research design will help the researcher to carry out the study systematically. 5.3 Purpose of research design. The research design serves the following purposes in conducting research. A research design helps the investigator to obtain answers to research problems and issues involved in the research, since it is the outline of the entire research process. Design also tells us how to collect data, what observations are to be carried out, how to make them, and how to analyze the data. Design also guides the investigator about statistical techniques to be used for analysis. Design also guides the control of certain variables in experimental research. Thus, the design guides the investigator to carry out research step by step in an efficient way. 5.4 Need for research design. Research designs are needed to enable the researcher to answer research questions as validly, objectively, accurately, and economically as possible. Research design also facilitates the smooth sailing of the various research operations, thereby making research as efficient as possible, yielding maximal information with minimal expenditure of effort, time, and money. Just as for happy and sound family life, we need a strong and cordial relationship between husband and wife. With in-laws, parents and children, and among siblings, we need a sound research design or a research plan prior to data collection and analysis of the research project. Research design stands for advanced planning of the methods to be adopted for collecting the relevant data and the techniques to be used in their analysis, keeping in view the objectives of the research and the availability of staff, time, and money. Research design, in fact, has a great bearing on the reliability of the results arrived at, and as such, constitutes the firm foundation of the entire structure of the research work. Lack of thoughtfulness in designing the research plan may result in rendering the research exercise futile. It is, therefore, imperative that an efficient and appropriate design must be prepared before starting research operations. The design helps the researcher to organize her or his ideas in a form whereby it will be possible for her or him to look for flaws and inadequacies. Such a design can even be given to others for their comments and critical evaluation to provide a comprehensive review of the proposed study. 5.5 Features of a good research design. A good research design is often characterized by adjectives like flexible, appropriate, efficient, economical, and so on. Generally, the design which minimizes the bias and maximizes the reliability of the collected data and analysis is considered a good design. The design which gives the smallest experimental error is supposed to be the best design in many investigations. Similarly, the design which yields maximal information and provides an opportunity for considering many different aspects of a problem is considered the most appropriate and efficient design in respect of many research problems. Thus, the question of good design is related to the purpose or objective of the research problem, and also with the nature of the problem to be studied. A design may be quite suitable in one case, but may be found wanting in one respect or the other in the context of some other research problem. One single design cannot serve the purpose of all types of research problems. A research design appropriate for a particular research problem usually involves the consideration of the following factors. 1. The means of obtaining information. 2. The availability and skills of the researcher and her or his staff. 3. The objective of the problem to be studied. 4. The nature of the research problem. And 5. The availability of time and money for the research work. If the research study happens to be an exploratory or a formulative one, wherein the major emphasis is on the discovery of ideas and insights, the research design most appropriate must be flexible enough to permit the consideration of many different aspects of a phenomenon. But when the purpose of a study is the accurate description of a situation or of an association between variables, or in what are called the descriptive studies, accuracy becomes a major consideration, and a research design which minimizes bias and maximizes the reliability of the evidence collected is considered a good design. Studies involving the testing of a hypothesis of a causal relationship between variables require a design that will permit inferences about causality in addition to the minimization of bias and maximization of reliability. But in practice, it is the most difficult task to put a particular study in a particular group. For a given research may have in it elements of two or more of the functions of different kinds of studies. It is only on the basis of its primary function that a study can be categorized either as an exploratory, descriptive, or hypothesis testing study. And accordingly, the choice of a research design may be made in the case of a particular study. Besides, the availability of time, money, skills of the research staff, and the means of obtaining the information must be given due weightage while working out the relevant details of the research design, such as experimental design, survey design, sample design, and the like. 5.5 Principles of Research Design. In designing social research, there are a number of considerations and principles that are worth taking into account to help create valid results. The conclusions that you can draw from your analysis will depend strongly on the principles you use. 1. Bias minimization. Researchers can easily introduce bias into results by accidental or subconscious means or otherwise reduce the validity of the methods used. Many of the methods used seek to reduce this bias. The subjects of research may also introduce their own bias, for example, through social desirability bias. What is said to them and what they understand may differ and needs careful consideration, although this may raise ethical concerns. 2. Sampling. It is seldom possible to research an entire population, so a sample must be selected to represent the population. After the experiment, statistical analysis can be used to enable generalization back to the population. There are many sampling methods that can be used, and the appropriate method needs to be carefully selected. Ideally, sampling is done randomly. In practice, samples are often selected based more on convenience and what is feasible. This need not invalidate experiments, but the analysis must be done carefully and conclusions drawn with care. 3. Randomization. If a random sample can be selected, then statistics can be used to generalize and draw conclusions about the entire population. Randomization is thus at the heart of a true experiment. Randomization also helps remove bias, where choices by the researcher, subject, or others may lead to invalid results. 4. Selection and assignment. Randomization starts with the selection of targets, random selection. It may also apply in deciding what treatments are applied to which subjects and when, random assignment. Where there are multiple groups, pre-selected subjects may be randomly assigned to groups. Random assignment is sometimes difficult, for example, in a study of 2 school classes in which natural groups have to be used. 5. Groups. Experiments often use multiple groups, with each group forming a mini experiment on its own, and with the findings from each group then being compared for further comparison, analysis, and conclusion. There are 2 main ways in which groups are used. These are as follows. Similar people in each group, but with different treatments. For example, in cluster sampling. Different types of people in each group, but with the same treatment applied to each. For example, in stratified sampling. The same group may also be given the same treatment, but at different times or in different contexts to see if they have changed or if they are affected by contextual factors. The context thus becomes part of the treatment. 6. Control group. A control group is one which includes the same type of people, preferably randomly assigned, as those in the treatment group. The control group is a useful way of eliminating extraneous variables and reducing noise. 7. Pre-test and post-test. Experiments that apply some kind of treatment apply a test or measurement in 2 places. Before the treatment, which is a pre-test, and after the treatment, which is a post-test. This allows for identifying change caused by the treatment by comparing before and after results from a similar test, for example, a change in skill, attitude, etc. 5.7 Research approaches. There are 2 basic approaches to research, viz., quantitative approach and qualitative approach. The former involves the generation of data in quantitative form, which can be subjected to rigorous quantitative analysis in a formal and rigid fashion. This approach can be further subclassified into inferential, experimental, and simulation approaches to research. The purpose of inferential approach to research is to form a database from which to infer characteristics or relationships of a population. This usually means survey research, where a sample of the population is studied, questioned, or observed to determine its characteristics, and it is then inferred that the population has the same characteristics. Experimental approach is characterized by much greater control over the research environment, and in this case, some variables are manipulated to observe their effect on other variables. Simulation approach involves the construction of an artificial environment within which relevant information and data can be generated. This permits an observation of the dynamic behavior of a system or its subsystem under controlled conditions. The term simulation in the context of social science applications refers to the operation of a numerical model that represents the structure of a dynamic process. Given the values of initial conditions, parameters, and exogenous variables, a simulation is run to represent the behavior of the process over time. Simulation approach can also be useful in building models for understanding future conditions. Qualitative approach to research is concerned with subjective assessment of attitudes, opinions, and behavior. Research in such a situation is a function of the researcher's insights and impressions. Such an approach to research generates results either in non-quantitative form or in forms which are not subjected to rigorous quantitative analysis. Generally, the techniques of focus group interviews, projective techniques, and in-depth interviews are used. Qualitative research versus quantitative research. Quantitative research is based on the measurement of quantity or amount. It is applicable to phenomena that can be expressed in terms of quantity. Qualitative research, on the other hand, is concerned with qualitative phenomena, that is, phenomena relating to or involving quality or kind. For instance, when we are interested in investigating the reasons for human behavior, i.e., why people think or do certain things, we quite often talk of my motivation research, an important type of qualitative research. This type of research aims at discovering the underlying motives and desires using in-depth interviews for the purpose. Other techniques of such research are word association tests, sentence completion tests, story completion tests, and similar other projective techniques. Attitude or opinion research, that is, research designed to find out how people feel or what they think about a particular subject or institution, is also qualitative research. Qualitative research is especially important in the behavioral sciences, where the aim is to discover the underlying motives of human behavior. Through such research, we can analyze the various factors which motivate people to behave in a particular manner or which make people like or dislike a particular thing. It may be stated, however, that to apply qualitative research in practice is relatively a difficult job. 5.8 Types of Research Designs. Different research designs can be conveniently described if we categorize them as 1. Research design in case of exploratory research studies, 2. Research design in case of descriptive and diagnostic research studies, and 3. Research design in case of hypothesis testing research studies. 5.8.1 Research design in case of exploratory research studies. Exploratory research studies are also termed as formulative research studies. The main purpose of such studies is that of formulating a problem for more precise investigation, or of developing the working hypothesis from an operational point of view. The major emphasis in such studies is on the discovery of ideas and insights. As such, the research design appropriate for such studies must be flexible enough to provide opportunity for considering different aspects of a problem under study. Inbuilt flexibility in research design is needed because the research problem, broadly defined initially, is transformed into one with more precise meaning in exploratory studies, which fact may necessitate changes in the research procedure for gathering relevant data. Generally, the following three methods in the context of research design for such studies are talked about. A. The survey of concerning literature. B. The experience survey. And C. The analysis of insight-stimulating examples. The survey of concerning literature. It happens to be the most simple and fruitful method of formulating precisely the research problem or developing hypotheses. Hypotheses stated by earlier workers may be reviewed and their usefulness evaluated as a basis for further research. It may also be considered whether the already stated hypotheses suggest new hypotheses. In this way, the researcher should review and build upon the work already done by others, but in cases where hypotheses have not yet been formulated, her task is to review the available material for deriving the relevant hypotheses from it. Experience survey. It means the survey of people who have had practical experience with the problem to be studied. The object of such a survey is to obtain insight into the relationships between variables and new ideas relating to the research problem. For such a survey, people who are competent and can contribute new ideas may be carefully selected as respondents to ensure a representation of different types of experience. The respondents so selected may then be interviewed by the investigator. The researcher must prepare an interview schedule for the systematic questioning of informants. But the interview must ensure flexibility in the sense that the respondents should be allowed to raise issues and questions which the investigator has not previously considered. This survey may as well provide information about the practical possibilities for doing different types of research. Analysis of insight-stimulating examples. It is also a fruitful method for suggesting hypotheses for research. It is particularly suitable in areas where there is little experience to serve as a guide. This method consists of the intensive study of selected instances of the phenomenon in which one is interested. For this purpose, the existing records, if any, may be examined, unstructured interviewing may take place, or some other approach may be adopted. Thus, in an exploratory or formulative research study, which merely leads to insights or hypotheses, whatever method or research design outlined above is adopted. The only thing essential is that it must continue to remain flexible so that many different facets of a problem may be considered as and when they arise and come to the notice of the researcher. Advantages of research design. Large amounts of information can be obtained from a large population in an economical manner, which is surprisingly accurate. Disadvantages of research design. Information tends to be superficial as breadth is emphasized. Expertise in sampling techniques, questionnaire construction, interviewing, and data analysis is required to produce a reliable and valid study. These designs are time-consuming and are sometimes costly. 5.8.2 Research Design in Case of Descriptive and Diagnostic Research Studies. Descriptive research studies are those studies which are concerned with describing the characteristics of a particular individual or of a group, whereas diagnostic research studies determine the frequency with which something occurs or its association with something else. The studies concerning whether certain variables are associated are examples of diagnostic research studies. As against this, studies concerned with specific predictions, with narration of facts and characteristics concerning an individual, group, or situation are all examples of descriptive research studies. Most of the social research comes under this category. From the point of view of the research design, the descriptive as well as diagnostic studies share common requirements, and as such, we may group together these two types of research studies. In descriptive as well as in diagnostic studies, the researcher must be able to define clearly what she or he wants to measure and must find adequate methods for measuring it, along with a clear-cut definition of the population she or he wants to study. Since the aim is to obtain complete and accurate information in the said studies, the procedure to be used must be carefully planned. The design in such studies must be rigid and not flexible and must focus attention on the following. A. Formulating the objective of the study. What the study is about and why is it being made. B. Designing the methods of data collection. What techniques of gathering data will be adopted. C. Selecting the sample. How many subjects will be needed. D. Collecting the data. Where can the required data be found and in what time period should the data be collected? E. Processing and analyzing the data. And F. Reporting the findings. In a descriptive or diagnostic study, the first step is to specify the objectives with sufficient precision to ensure that the data collected are relevant. If this is not done carefully, the study may not provide the desired information. Then comes the question of selecting the methods by which the data are to be obtained. In other words, techniques for collecting the information must be devised. Several methods, viz., observation, questionnaires, interviewing, examination of records, etc., with their merits and limitations, are available for the purpose, and the researcher may use one or more of these methods, which have been discussed in detail in Block 2 of this course. While designing the data collection procedure, adequate safeguards against bias and unreliability must be ensured. Whichever method is selected, questions must be well examined and made unambiguous. Interviewers must be instructed not to express their own opinion. Observers must be trained so that they uniformly record a given item of behavior. To obtain data free from errors introduced by those responsible for collecting them, it is necessary to supervise closely the staff of field workers as they collect and record information. As data are collected, they should be examined for completeness, comprehensibility, consistency, and reliability. The data collected must be processed and analyzed. This includes steps like coding the interview replies, observations, etc., tabulating the data, and performing several statistical computations. To the extent possible, the processing and analyzing procedure should be planned in detail before actual work is started. This will prove economical in the sense that the researcher may avoid unnecessary labor, such as preparing tables for which she or he later finds she or he has no use, or, on the other hand, redoing some tables because the researcher failed to include relevant data. Coding should be done carefully to avoid errors in coding. Finally, statistical computations are needed, and as such, averages, percentages, and various coefficients must be worked out. Last of all, arises the question of reporting the findings. This is the task of communicating the findings to others, and the researcher must do it in an efficient manner. The layout of the report needs to be well planned so that all things relating to the research study may be well presented in a simple and effective style. Advantages. The subject is being observed in a completely natural and unchanged natural environment. A good example of this would be an anthropologist who wanted to study a tribe without affecting their normal behavior in any way. True experiments, whilst giving analyzable data, often adversely influence the normal behavior of the subject. Descriptive research is often used as a precursor to quantitative research designs, the general overview giving some valuable pointers as to what variables are worth testing quantitatively. Quantitative experiments are often expensive and time-consuming, so it is often good sense to get an idea of what hypotheses are worth testing. Disadvantages. Because there are no variables manipulated, there is no way to statistically analyze the results. Many scientists regard this type of study as very unreliable. Here is the text with study as very unreliable and unscientific. In addition, the results of observational studies are not repeatable, and so there can be no replication of the experiment and reviewing of the results. Top 5.3 Research Design in Case of Hypothesis Testing Research Studies. Hypothesis testing research studies, generally known as experimental studies, are those where the researcher tests the hypotheses of causal relationships between variables. Such studies require procedures that will not only reduce bias and increase reliability, but will permit drawing inferences about causality. Usually, experiments meet this requirement. Hence, when we talk of research design in such studies, we often mean the design of experiments. As such, the study of experimental designs has origin in agricultural research. Professor Fisher found that by dividing agricultural fields or plots into different blocks, and then by conducting experiments in each of these blocks, whatever information is collected and inferences drawn from them happen to be more reliable. Today, the experimental designs are being used in researches relating to phenomena of several disciplines. Since experimental designs originated in the context of agricultural operations, we still use, though in a technical sense, several terms of agriculture, such as treatment, yield, plot, block, etc., in experimental designs. Depending on the degree of control, we may classify the experimental design in the following 5 categories. 1. Trial and error experiment. This is the earliest form of experimental design, in which the researcher does not prepare a structured plan of studies, but prepares a hypothesis and tries to test it in an actual social condition. Thus, based upon her or his experiences, she or he changes the methods and techniques of the study. This design is said to be a poor design. 2. Controlled observation studies. As the title indicates, under this design, the researcher observes the phenomenon under controlled conditions. The researcher may introduce a new stimulus or a new element in the treatment group and not allow the control group to participate in that situation or with the new element. The difference between the two groups vis-a-vis the relevant variable may also occur naturally, e.g., smokers and non-smokers, who may be compared without any active manipulation by the researcher. 3. Natural experiment. The designs which are planned for the study in the natural setting are known as natural experiments. This is one of the most commonly used designs in the field of psychology, sociology, and extension education. The limitation of this design is that the situation can be influenced by growth factors, publicity, propaganda, and other variables operating upon the situation. 4. Ex post facto techniques. When the study moves from present to future, basing the interpretation on past happenings or the facts that have already occurred, the design employed is known as ex post facto design. The literal meaning of ex post facto is from what is done afterwards, or something occurring after an event, with a retrospective effect on the event. In this design, the researcher cannot manipulate or assign subjects for treatment and observe the effect because the event has already happened. 5. Laboratory experimental design. Laboratory experiment connotes a controlled scientific investigation under a lab situation in which an investigator manipulates and controls one or more independent variables and observes the dependent variable or variables for variation concomitant to the manipulation of the independent variables, Kurlinger. Laboratory experimental design, then, is one in which the investigator has direct control over at least one independent variable. Thus, the experimental design is the ideal of scientific endeavor, which has the unique virtue of experimental inquiry that is controlled under laboratory conditions. Advantages of experimental research design. This type of research draws a conclusion by comparing subjects against a control group, in cases where the researcher has no control over the experiment. For example, a research study comparing the risk of developing lung cancer between smokers and non-smokers would be a good example of an observational study. The main reason for performing any observational research is due to ethical concerns. With the smoking example, a scientist cannot give cigarettes to non-smokers for 20 years and compare them with a control group. This also brings up the other good reason for such studies, in that few researchers can study the long-term effects of certain variables, especially when it runs into decades. For this study of long-term and subtle effects, they have to use pre-existing conditions and medical records. The researcher may want to study an extremely small sample group, so it is easier to start with known cases and work backwards. The thalidomide cases, for example, are an example of an observational study where researchers had to work backwards and establish that the drug was the cause of disabilities. An observational study allows a useful insight into a phenomenon and sidesteps the ethical and practical difficulties of setting up a large and cumbersome medical research project. The results of a true experimental design can be statistically analyzed, and so there can be little argument about the results. It is also much easier for other researchers to replicate the experiment and validate the results. For physical, mainly numerical data, it is much easier to manipulate one variable, so true experimental design usually gives a yes or no answer. Disadvantages of experimental research design. The main problem with observational studies is that the experimenter has no control over the composition of the control groups and cannot randomize the allocation of subjects. This can create bias and can also mask cause and effect relationships, or, alternatively, suggest correlations where there are none, error in research. For example, in the smoking example, if the researcher found that there is a correlation between smoking and increased rates of lung cancer, without knowing the full and complete background of the subjects, there is no way of determining whether other factors were involved, such as diet, occupation, or genetics. Randomization is assumed to even out external causal effects, but this is impossible in an observational study. They can be almost too perfect, with the conditions being under complete control and not being representative of real-world conditions. For psychologists and behavioral biologists, for example, there can never be any guarantee that a human or living organism will exhibit normal behavior under experimental conditions. True experiments can be too accurate, and it is very difficult to obtain a complete rejection or acceptance of a hypothesis because the standards of proof required are so difficult to reach. True experiments are also difficult and expensive to set up. They can also be very impractical. While for some fields, like physics, there are not as many variables, so the design is easy, for social sciences and biological sciences, where variations are not so clearly defined, it is much more difficult to exclude other factors that may be affecting the manipulated variable. Field experiments can suffer from a lack of a discrete control group and often have many variables to try to eliminate. For example, if the effects of a medicine are studied and the subject is instructed not to drink alcohol, there is no guarantee that the subject followed the instructions. So field studies often sacrifice internal validity for external validity. In ex post facto research design, the researcher cannot manipulate or assign subject or treatment and observe the effect because the event has already happened. 5.9, let us sum up. In this unit, we have learned the meaning of research design, purpose, and its features. The approaches to any research are qualitative and quantitative. There are the principles of research on which depends the overall research plan. As discussed in the unit, the research design is the blueprint, which is similar to what is made for our house before construction. Depending on these, the research can proceed further to arrive at the conclusions. It all depends on the type of research problem. The research can be directed by one of the types of research designs. The various types of research designs have been discussed in this unit, along with their advantages and disadvantages. 5.10, qualitative phenomena, phenomena relating to or involving quality or kind. Attitude or opinion research, research designed to find out how people feel or what they think about a particular subject or institution. Experimental studies, hypothesis testing research studies.